Hi class, right now we're going to get into some application problems. So for application problems, we have to know the formula, and I have written down the formula for you. A equals P times 1 plus R over N to the NT. This is for compounding periods problem. So every time you see the word compounded, you're going to have to use this formula. And you see right there, I put P is the principal, which is the initial amount. A is the final amount. R is rate, T is time, and N is the number of compounding periods. So for N, when they compound it annually, that means N is 1. Semi-annually, N is 2. Quarterly, N is 4. Monthly, N is 12. So that's pretty much how many times they calculate the interest. Right here, for our current problems, we have compounded annually. So N is 1 in this case. So I'm just going to fill in everything we have. Notice that they ask you how many years. So they're asking you for the time. Um, so the principal is 3,000. How many years will it take to accumulate 6,000? So A is going to be 6,000. P is 3,000. 1 plus R is 6.75%. So you want to change to decimal. It's going to be 0.0675 over, like I mentioned, N is 1. 1 times T. Okay, so what we have right here, you're just going to follow the order of operation. You can see that we can take care of the inside parenthesis. So we have 6,000, 3,000, 1.0675 T. Now you can see that you can get rid of 3,000. Okay, so it's going to be 2. 1.0675 T. Now, how do we solve for T? You need to bring T down. So the one way we can do that is we're going to have to apply either ln or log. So I can use the property. So I'm going to use ln. So what I have is going to be ln2 equals T ln 1.0675. So now to solve for t, I'm just going to divide ln2 divide by ln 1.0675. All right, I'm going to use a calculator for that. So what I have is ln2. I'm going to close the parenthesis there. Ln2 divide by ln 1.0675. So you can see that is approximately 10.661. So I'm going to round it. So round it to the whole number. So it's going to be 11 years. Right? Moving on, number 20. So 20 is similar. They're asking you how long. So once again, they ask you for the time, T. But this time, you see that we have compounded monthly. So A is going to be 6264. P is 4,000. 1 plus R is 0.102 over, this time N is going to be 12. And then I have 12 times t. Okay. So what I have, once again, I'm gonna go ahead and simplify the inside. So what I have, divide by 12. So what I have inside is 1.0085 to the 12t. Okay. Now, like I said, I have to divide 4,000. So I have, so we can cancel that. Now, once again, I'm going to apply ln. So I'm going to do ln 6264 divided by 4,000 equals 12t ln of 1.0085. And you can see that you can divide 12 times ln. So what I'm going to do is I'm going to take the whole thing right there, divide by 12, ln of 1.0085. Now, if you have a good scientific calculator, you can just enter everything as you see on the screen. If you don't have a graphing calculator or a good scientific calculator, you can just follow the order of operation. So we're going to use a calculator for this. So I'm going to put the parenthesis for everything. So I'm going to put first parenthesis, we have ln 6264 divided by 4,000. I'm going to close that parenthesis. Divide by parenthesis 12. I just want to include all the parentheses there so we don't make any mistake. Then I'm going to close that parenthesis. So what I have is 4.415. So when you round it, it's going to be 4.42 years. Okay. All right. Moving on to number 21. So for number 21, what we have is compounded continuously. So we have a new formula for it. I always call it A PERT. So A equals to P E to the RT. So we don't have the number of compounding periods, so we have to use a different formula. So what do we have right here? They're asking you to find the amount owed. So they pretty much asking you for the final amount, right? So you borrow. So we borrow 1,800 with the rate 0.03 for 7 years. So pretty much we use a calculator for this. It's straightforward, right? So I have 1,800. We multiply by the E. So E is the second function of ln. There. And then we have 0.03 times 7. So that's the amount. I'm going to round it 62 cents. Okay. So if we borrow 1,800 with that rate after 7 years, the final amount is going to be roughly 2,200. Okay. So what I have, the next problem, same thing. What we have is compounded continuously, so we have to use the same formula. So we have how much money should they invest now? So they're asking you for P, and in order to be able to contribute 8,500 to his education. So 8,500, that's going to be your final P E to the RT. Oh, we know R. So R is 0.08 and T is 13 years. Okay, so slightly different because this time you're looking for P, so I have to divide. And then you once again use the calculator for it. Okay, so I have 8,500 divide by, I'm going to put parenthesis just to be sure. Okay, so that's going to be the principal. Nearest cent. So it's going to be 36 cents. Okay, moving on to number 23. You see right here what we have is the continuous exponential growth model. So for this one right here, you just have to watch out for two things. If it's a growth model, then the rate is going to be positive. If it's decay, then the rate is going to be negative. So what I have right here, um, right here is the continuous exponential growth model. Okay, so the sample increases and continuously at the rate 19% per day. Find the mass of the sample after 2 days. So we have P, we're looking for A. For 53 E, same thing, same formula. I have R is 0.19, and then we have after 2 days, so it's time 2. Okay. Now, by the way, for these problems, if you make mistake, you can tell because the answer is gonna come out really weird. Okay, so it's gonna be 662.4 grams. Okay. Now, if they're asking you for the final amount and you have like a negative number, then you know something wrong, right? Or the number doesn't make sense. This is growth. So if it's less than 453, it doesn't make sense. So you should analyze your final solution. Okay, 24. We have the exponential growth model. But this time they're asking you find the hourly growth rate. So they're asking you for the rate. Now we have the final as 1273. The principal is 1200. And then we don't know rate. We're looking for rate, but we do know the time, which is 2 hours. So I have 2 times R. Okay, and once again, we're gonna go ahead and just apply the ln so we can move the r to the front. So first, I can always divide the 1200 e to the 2r, and then I'm gonna apply ln. So my answer, I can just take that and I divide by. Don't forget that when I apply ln, I can just move this to the front. Oh, by the way, ln is cancel out, right? Ln e cancel out. So when it's come to e, you should apply ln, not log. Okay, so ln and e cancel out, so we get 2r. So you just have to take that number, that ln, divide by 2. Okay, and then we should get the answer. In this case, I can hit the enter right away, and then I can take that, and then, oh, I'm sorry, divide. So I can take the answer and then divide by 2. Okay. So what we have is 0.029. So make sure you change to percent. So if I change to percent, that would be 2.95%. Okay, now moving on to number 25, we have the model right there. Now you have to notice that we have they're asking you for hours, so they're asking you for time, right? Now they don't give you the initial and the final. The only thing we know is the size of the sample is going to be double. Okay, so if y naught is 1, y is going to be 2. So that's how I set it up, the equation. So it's going to be 2 double it. So 2y naught equals to y naught e 0.067. They're asking you for time, so t. Okay, so I can just divide. So what we have is 2. So we cancel it out, right? Now I can apply the ln one more time. So I can apply ln, and the e is going to cancel out. So ln here, so e cancel out. So I ended up with ln 2 equals to 0.067 t. So in order to solve for t, you just divide, right? So I take ln 2, divide by 0.067, and then we should get the answer. 10.3 hours. And that's your final answer.